For over a century, the field of condensed matter physics has been haunted by a single, elusive goal: the discovery of a material that can conduct electricity with zero resistance at room temperature. We have known since 1911 that certain metals can achieve this state, but only at temperatures approaching absolute zero, conditions that require expensive, complex liquid helium cooling systems. This physical limitation has meant that roughly 5 to 10% of all electricity generated in the United States is lost as heat before it ever reaches a consumer. But as we move through 2026, the era of electrical friction is finally coming to an end. We are witnessing a fundamental shift in the material supremacy, where the mastery of electron flow is no longer a laboratory curiosity, but a pillar of national infrastructure and industrial dominance. The breakthrough that has defined 2026 occurred earlier this year, when a multi-institutional team verified a superconducting transition at 151 Kelvin. While this temperature, roughly negative 188 degrees Fahrenheit, still sounds incredibly cold, it represents a massive leap forward when paired with a revolutionary technique known as pressure quenching. Traditionally, high-temperature superconductors required pressures equivalent to those found at the center of the Earth to function. The 2026 innovation involves using carbon-based hydrogen compounds that are squeezed under intense pressure and then quenched or chemically locked into that state. This allows the material to maintain its superconducting properties even after the external pressure is removed. For the first time in history, we have a stable, verified roadmap to materials that can operate at ambient pressures and increasingly accessible temperatures. The implications for the American economy and the average citizen over the age of 50 are profound. We are looking at the total obsolescence of the traditional, aging power grid. By replacing copper transmission lines with superconducting cables, we could theoretically power the entire United States using a fraction of the current generation capacity, simply by eliminating the waste. This isn't just about lower utility bills. It's about a grid that is immune to the heating and sag that causes traditional lines to fail during peak summer demand. Furthermore, this technology is the key to a new generation of medical diagnostics. Current MRI machines are massive, multi-million-dollar installations because they require liquid helium to cool their superconducting magnets. Room temperature, or even near-room temperature superconductors, would allow for portable, high-resolution MRI units in every local clinic, transforming preventative healthcare for a maturing population. Beyond energy and medicine, 2026 has seen a surge in the superconductor patent race. Industrial giants and defense contractors are aggressively filing for intellectual property related to these pressurized hydrogen lattices. The reason is simple. Whoever owns the primary patents on lossless conduction will effectively own the 21st century's most important utility. From high-speed maglev trains that glide silently between American cities to quantum computers that operate without the massive cooling arrays of the past, the applications are limitless. This is a quiet revolution happening at the atomic level, where the way we move energy, data, and even people is being rewritten. As we look toward the final months of 2026, the focus has shifted from "can it be done" to "how fast can we scale it?" The transition from silicon and copper to these advanced superconducting alloys is the defining scientific achievement of our decade. It represents the ultimate victory over the laws of thermodynamics that have constrained human engineering since the dawn of the Industrial Revolution. We are no longer just managing the loss of energy. We are entering an era of total efficiency. The 2026 quantum leap is more than a headline. It is the foundation of a frictionless world, securing a future of abundance, stability, and American technological leadership for generations to come.